We will now evaluate this integral and verify the result by differentiation. So first, I'm going to consider the terms inside the integral. That is, this is the term that we have to integrate. So this terms, which is basically a rational function, I'm going to consider as f of x. So I write f of x equivalent to x squared plus 2x minus 3 in the numerator, and in the denominator I have x power 4. So I can divide all the terms of the numerator by the denominator term, which means I can write down like this: x squared by x power 4 plus 2x divided by x power 4 minus 3 divided by x power 4. We just correct this. This is x power 4 and this is also x power 4. So we can further simplify this. This is x squared divided by x power 4 is 1 by x squared, and 2x divided by x power 4 is 2 by x cube minus 3 by x power 4. So we will utilize this form of f of x to integrate and then verify the result by differentiation. So let me integrate this form of f of x. I'm going to copy it here. So basically I'm going to integrate this 1 by x squared plus 2 by x cube minus 3 by x power 4 dx. So for integration, we cannot integrate these terms like this. We have to write in a different form. So which can be written as 1 by x squared. We basically integrate each terms one by one like this. And then we have this term 2 by x squared, x cube. I can factor out the 2 and then integrate only the x cube term. So it becomes like this. And then for the next term, I have minus 3 by x power 4, which can also be factored. That is, I factor out the 3 and then integrate only the x power 4. So I write down like this. Now I had to integrate each terms one by one. The first term is 1 by x squared, the second term is 1 by x cubed, and the third term is 1 by x power 4. So first I'm going to write down this in a better form so that I can apply the power rule of integration, that is this rule. So for that it has to be in the form of x raised to the power of some n. So here it is in the form of rational function. So in 1 by x squared can be written as x raised to the power of minus 2. So I read it like this. Similarly, 1 by x cubed can be written as x raised to the power of minus 3. And then I have minus 3. 1 by x power 4 can be written as x raised to the power of minus 4 dx. So now I can apply the power rule of integration. So I'm going to apply this rule, which says if you have a function x raised to the power of n, and if you integrate it, it is equal to x raised to the power of n plus 1 divided by n plus 1 plus the constant of integration, and n should not be equal to minus 1. So let's do that. So here this becomes x raised to the power of minus 2 plus 1 divided by minus 2 plus 1. And similarly, 2 times of x raised to the power of minus 3 plus 1 divided by minus 3 plus 1, minus 3 times of x raised to the power of minus 4 plus 1 divided by minus 4 plus 1. And finally, I put the constant of integration, that is c. So let's simplify or rewrite this in a better form. So this is equal to x raised to the power of minus 1 divided by minus 1 plus 2 times of x raised to the power of minus 2 divided by minus 2 minus 3 times of x raised to the power of minus 3 divided by minus 3 plus constant of integration. Let me simplify this. So this can be written as we have minus 1 in the denominator, so this can be written as minus 1, and x raised to the power of minus 1 can be written as minus 1 by x. And similarly, I can cancel this positive 2 with negative 2 as minus 1 times. And similarly, I can cancel this negative 3 as well as this negative 3 with positive 1. So this means here I have negative x raised to the power of minus 2. I can write down this as x power 2. and here I have positive 1, so this becomes 1 by x cube plus c. So this is the result of integration. That is, when we use the f of x given as a rational function, we have written in terms of this form, and then we have integrated. So let's now verify the result by differentiation. So I'm going to copy this and differentiate this. So I write down as d by dx of minus 1 by x minus 1 by x squared plus 1 by x cube plus the constant c, which I can write down as differentiating each term. So I write down like this: d by dx of minus 1 by x. Basically, we are applying the sum rule. That is, when you differentiate the sum of terms, it's equivalent to differentiating each terms one by one. Then this becomes differentiation of minus 1 by x squared. Then we have the third term, that is differentiation of 1 by x cube plus differentiation of constant. Now we can rewrite this in different form so that we can apply the power rule of differentiation. This can be written as minus 1 x power minus 1. And the second term can be written as differentiation of minus 1 times of x power minus 2. And the third term can be written as d by dx of x power minus 3 plus differentiation of constant d by dx of the constant c. Now let's apply the power rule. That is, we are going to apply this power rule of differentiation. It says if you differentiate x raised to the power of n, this is equal to nx power n minus 1. So let's apply that here. I can write down the formula here. It is d by dx of x raised to the power of n is equal to nx power n minus 1. That is, basically you put the n in front and reduce the power by 1. So this means when you differentiate this negative 1 x power minus 1, I have this negative 1 and I take this negative 1, I put this in front and reduce the power by minus 1. So therefore this becomes x power minus 1 minus 1. And similarly, I differentiate the second term. I already have negative 1, and then here I have negative 2. So I put the negative 2 in front and reduce the power by 1. This becomes minus 2 minus 1. And similarly, I can do it for the next term. So therefore this becomes minus 3 times of x raised to the power of minus 3 minus 1. Plus the differentiation of this constant is 0. So let's simplify or write down in a better form. So this negative 1 times of negative 1 is positive 1, and x raised to the power of minus 1 is x raised to the power of minus 2. And then we have minus 1 times of minus 2 is positive 2 times of x raised to the power of minus 2 minus 1 is x raised to the power of minus 3. Plus we have a negative 3. So let me put as negative 3. This is minus 3 times of x raised to the power of minus 4. Now let's write down in terms of positive powers for x, which can be written as 1 by x squared plus 2 by x cube minus 3 by x power 4. Let's see if this is equivalent to f of x. Let's go back and verify if this is our f of x. We have 1 by x squared plus 2 by x cube minus 3 by x power 4. And here we have 1 by x squared plus 2 by x cube minus 3 by x power 4. And so I can write down this as f of x. So we differentiated the result of integration, that is after integration. When we differentiated the result after integrating the original f of x, we got back our original f of x.